Hello everyone. Today I'm doing linked list questions. Today is day 17. I am not doing all the questions in each topics because it's first of all it's boring, and second uh, I plan to do a few questions in each topic so that I get familiar with all the topics, and then I'll do questions randomly. So we'll start with linked list now. What is a linked list? Imagine you are given a task where you have to maintain a data entry of cars entering a parking lot. Since the number of cars entering will be different and may change daily, constructing a fixed size data structure like an array might not be helpful. This is when linked list come into picture, which allows us to add and remove cars easily. Linked list is a linear data structure that can be visualized as a chain with different nodes connected, where each node represents a different element. The difference between array and linked list is that unlike arrays, the elements are not stored at a contiguous location. For an element to be added in an array, we need the exact next memory location to be empty, and it is impossible to guarantee that it is possible. Hence, adding elements to an array is not possible after the initial assignment of the size. So this is an array where memory is allocated in contiguous locations, whereas in linked list these locations can be anywhere in the memory, but they are just connected with next pointer. A linked list is a data structure containing two crucial pieces of information. The first is the data and the other is the pointer to the next element. The head is the first node and tail is the last node. Creating a linked list, there are two information sets to store at every node. Thus there is a need to create a self-defined data type to handle them. Therefore we will use the help of struct and classes. So we have created a class called node, in which we have in data and we have a pointer to the next node. Then we have a constructor data and next one, and we have one more constructor with the data and next pointer to null. Then in the main method we have an array, and we are creating the first node by this constructor. So the next pointer will point to null for the first node, and we are also printing the memory reference of the node. So we'll print y, and then we can print the data stored in node by y.data. This class has two data types: data, which contains the value, and pointer to the pointer next, which points to the next node. There is a constructor which assigns the value to a new node. A new keyword is used to dynamically allocate the memory. Understanding pointers. A pointer is a variable that stores the memory address of another variable. In simpler terms, it points to the location in memory where data is stored. This allows us to indirectly access and manipulate data by referring to its memory address. Java does not explicitly use pointers or take the address of variable as you do in C++. Instead, we have a reference variable. The reference variable do not directly contain memory address like pointers in language like C and C++. Instead, they hold reference to the object in the memory. Understanding the difference between node and node asterisk. A node refers to the structure that contains the data and pointer to the next node. In contrast, node asterisk or node pointer specifically denotes a pointer variable that stores the address of the node it is pointing to. So this is node pointer which contains the address, and this is node which contains the data and next, which is the reference of node. Memory space. Let's talk about assuming the data stored in integer. Another main difference between an array and linked list is the memory used. In case of array, we are storing integer that consumes 4 bytes of data for every int, whereas in linked list we are storing data as well as pointer to the next node. So the memory used up is depending upon the configuration of the system. In 32-bit system, int is 4 byte, pointer is 4 byte, and in 64 this is 4 byte and pointer is 8 byte. So overall this contains 8 byte and this contains 12 byte. Applications of linked list. Creating data structure. Linked list serves as a foundation for building other dynamic data structures such as stack and queue, dynamic memory allocation, A dynamic memory allocation relies on linked list to manage and allocate memory block efficiently. Web browser is one important application of linked list. Types of linked list. Singly linked list is that in each node points to the next pointer in the sequence. Traversal is straightforward but limited to moving in one direction from head to toe. So in linked list, each node points to the next node and last node points to null. Doubly linked list, in this each node points to both the next and the previous node, thus allowing it bi-directional connection. So in this, if we have reference to this node, we can traverse only forward. If we have reference to C, we can get address of D and so on, but we cannot traverse backward. We will never know the addresses of A and B. But in doubly linked list, we have linked list, each node stores the address of previous and next node. So traversal is possible in both directions. And then we have circular linked list, in which last node, instead of pointing it to null, it points to the first node. So this is a circular linked list. Then we have insertion at the head of the linked list. Given a linked list and an integer value val, insert a new node with that value at the beginning of the list and return the updated linked list. So if this is the linked list and this is the value, we need to insert it at the head. This is pretty straightforward. They haven't given ID or lead code. Is this question present or on lead code? This is not the question. Okay, I'll write it down here directly. So example is, we need to insert the value of 5 before the head of the given linked list, and head will be provided, right? So let's say in this method we are given head, which is the start pointer. So what we'll do is, we'll return, and we are given an int value. So we'll create a new node with this value, that will be list node equals head, new node equals to new list node, and with this value, and then we'll make new node dot next will be head. So now we have connected the new node at the start, and we'll return the new node. That should be it. Right. Let's see the approach. Code. So what we are doing here is, we are creating a new node, and we are making, what is the question? One second. Given a linked list and an integer val, insert the new node with the val at the beginning before the head of the and return the updated linked list. Acha, this is for the creation of linked list. Then we are inserting it at the end. Insert at the head method, where is it? Insert at the head is new node, and they have the other constructor as well, so this will become the next. Okay, fine. Then we have deletion of linked list. Deletion of linked list. Here there was node and nothing else. This was the original code. there is a singly linked list head and we want to delete a node in it. So there is a linked list and we need to delete this particular node from it. You are given the node to be deleted node. You will not be given access to the first node head. Okay. All the values of the linked list are unique and it is guaranteed that the given node is not the last node in the linked list. So this is not the last node. Delete the given node. Note that by deleting the node, we do not mean remove it from the memory. We mean the value of the given node should not exist in the linked list. The number of nodes in the linked list should decrease by 1 and all the values before node should be in the same order. All the values after node should be in the same order. Custom testing. For this input, you should be providing the entire linked list head and the node should not be last. Okay, fine. So basically if node is 5, we need to remove it and then 4 should be connected to 1. So in order to do that, we need the as this is a singular what we call it, singly linked list what we call it, sorry, singly linked list, yeah. So if it is a singly linked list, then we can only traverse forward. If we are given the address of this node, we are given node, so we don't know the address of this, then we cannot connect this to remove this. Other way of doing this would be that, let's say if this linked list is given 4 5 6 7 8 and question is to delete 5, then what we can do is we can update the values of these nodes. So we are given 5, so we'll update the value of 5 to 6, then we'll update the value of 6 to 7, we update the value of 7 to the value of next node, which is 8, and we'll just point this to null. So this will make the result and now 5 is deleted. This is one way of doing this. In this we need to traverse from start to the end, so time complexity is order of n. In this case, one more way of doing this would be, instead of traversing the whole linked list, what we can do is, let's say we need to remove 5, so we'll update the value of this node with the value of next node, so this will become 6, and then we can remove 6. So for that we need to connect this node to this node, so 6 needs to be connected to 7 and 7 to 8. So basically what we are doing is, we are removing the first of all we are updating the value of node to the value of next node, and then we are making the value of node dot next equals to node dot next dot next. So I'll write it down. And what if node is this, then we cannot connect it. Okay, it cannot be last node, right? Node should not be the last node. Okay, it cannot be last node. So first of all we'll update the value node dot data node dot val equals to node dot next dot val, and then we need to update the next pointer of node dot next equals to node dot next dot next. That's all, I guess. Submit. Cool. Then we have given a head of linked list, print the length of the linked list. This is pretty simple. So we are given, let's say if we are given the head of linked list, we'll take a int length, we'll traverse while head is not null, we'll traverse it and we'll do length plus plus, and length will be initially 0 and head will be head dot next, and at the end we'll return head. That's all. Return length. Approach code Java solution. length of linked list. Where is the method length of linked list? Okay, so we are taking a counter. Instead of updating head, we are taking a temporary variable. Temp is not equals to null. Same thing they have done. Okay. Time complexity is order of n. Space complexity is order of 1. Then we have search in linked list. Given a head in the linked list and an integer value, find out whether the integer is present in the linked list or not. Return true if it is present, or else return false. So same thing we can do in this code. We have also given a value target which we need to search. So we'll keep doing this. We'll keep this while loop, and instead of checking the length, we can check the value. So if head dot value is equals to target, will return true, and at the end we can return false. That's all. And again, in this case also, as we are traversing the linked list, time complexity is order of n and space is order of 1. So same thing they are doing. Okay. Then we have introduction to doubly linked list. Before exploring doubly, let's refresh our knowledge on linked list is a linear data structure, it containing data and reference. This allows a dynamic. A significant character of linked list is unidirectional होता है, allowing traversal in only one direction, that is forward. Moving backward, such as going from third node to first, is not possible because each node is singly linked list, holds two precise data and pointer indicating the address on the next end. ठीक है. Doubly linked list, as the name suggests, allows two-way traversal by introducing two pointers in each node. This enables seamless traversal in both directions, making them a valuable tool for various advanced data structure applications. So in doubly linked list, we have data pointer, a next pointer, and a previous pointer. Okay. Next question is, given a doubly linked list and a value k, insert the node having value k at the end of the doubly linked list. Insert a node having value k at the end of the doubly linked list. Okay. So in this case, I'll again write it down on the same IDE. So if this is the doubly linked list, we need to insert it at the end. So what we'll do, we are given a head and we are given a target. We need to traverse till the end node. So while head dot next is not equals to null, will traverse head equals to head dot next. Now head is let's take a different variable, different reference for head node, otherwise we'll update the original pointer. So temp will be head. Now temp dot next equals to is not equals to null, and temp equals to temp dot next. Now what we'll do, now we are at the last pointer, so we need to update the next pointer of this. Instead of null, the next pointer will point to temp dot next will be a new node. Let's first create the new node, which will be the last node. So list node last equals to new list node, and it is with the target value. Now this will be last, and also last dot previous will be temp, and and last dot next will be null. That's all. I'll see the approach. So this is the method insert at the end. We have created the new node. We are checking if head is null, then this is the last node. Now we are traversing till the end. Okay, we have got tail as the last node. Tail dot next will be new node. Tail dot back they are taking instead of previous. So new node dot previous is tail and will return the head. Next question is, given a doubly linked list, delete the last node of the doubly linked list. Here in the question they have written, it's a silly mistake. You see here they are saying delete head of the doubly linked list, but the actual question is delete last node of the doubly linked list. Both we can do. So for deleting the last node, once we have reached this node, we'll just make a temp dot next equals to null. Oh, okay, wait, we need to delete the last node, right? So we need to traverse till temp dot next is not equals to null. So we are at second last node, and then we'll make temp dot next equals to null. That way we can delete the last node. Approach. Either we can do temp dot previous, because this is as the last node. They are looking for the last node. So last node previous dot next as null, or otherwise will stop at second last. That is also one way of doing this. Then we are given a doubly linked list of size n consists of positive integer. Your task is to reverse it and return the head of the modified doubly linked list. So this is the linked list, and we need to reverse it and give the reversed doubly linked list. So one way of doing this would be that we traverse this linked list, we store all the values in a list or array. Okay, we'll store each value in a list, and after storing we will traverse this list again and then store all the values in reverse order. But that will time complexity will be order of n, but space will be order of n as well. We are taking extra space to store these values. For doing this in place, what we can do is we can make we can return the address of the last node and say that is the first pointer. Isn't that going to give us the result? But previous, instead of head dot next previous होगा ना. 4 dot next should be 3, but if we return this as the head node, then 4 dot back is 3. So one way we can do is that at each iteration we keep track of the next node and update the pointers. So once we are here, we'll make 1 dot next as null, we'll keep track of the next node, and we'll update 1 dot next as null and 1 dot back as this node, because 1 dot back is 2. Then we are at this, we'll keep track of 3, we'll update 1 dot next as previous, and 1 dot next equals to 3. So at each index we'll keep track of 3 nodes: current node, previous node, and next node, and will update the pointers. I think it is doable. I don't think there is any issue in doing this. Let's see. So what they are doing is, reverse, they're swapping the pointers, same thing, huh? Let me do some questions, and then with these I want to do questions. Middle of a linked list, tortoise, what did it say? Tortoise hare method. Middle of linked list. Given a head of singly linked list, return the middle node of the linked list. If there are 2 middle nodes, return the second middle node. So in case there are odd number of elements, we need to return middle. If there are even, then there are 2 middle and we need to return the second middle. One way of doing this is that one way of doing is that we traverse this linked list, count the number of nodes in linked list, and then we'll find the n by 2th element, right? N by 2 plus 1 element. So if there are 5 nodes, then we need 5 by 2 is 2 plus 1 third element. If there are 6 nodes, so 6 by 2 is 3 plus 1 fourth element. That way we can do it by counting the number of nodes. Without counting the number of nodes, if we want to do it, then we can take 2 pointers. One will move faster, second will move slower. One will move 1 step and the other pointer will move 2 steps, and once the second pointer reaches the end, the first will reach in the middle. So what I'm saying is, let's say if this is the linked list 2, 3, 4 and 5, we'll take 2 pointers. One is slow pointer, second is fast pointer, both initially pointing at 1. Okay, now slow pointer moves only 1 step and fast pointer moves 2 steps. So in first iteration, slow will reach 2 and fast will reach 3. Then we need to do this until fast reaches the last pointer or at the end. So in second iteration, slow will reach 3 and fast will reach 5. Now fast is at the last node, right? That means we are at the middle element. And in case there are 6 elements, then that means there are even number of elements. So in next iteration, slow will reach 4 and fast will reach null, right? After fast 5 पे है तो 2 steps के बाद वो null पे चला जाएगा. तो either it reaches the last node or null. In any case, wherever slow is at, that will be the middle element. So we can write it quickly. We'll take 2 pointers. List node slow equals to head and list node fast equals to head. Also, if head is already null, then head can be null, right? No, number of nodes is greater than 1 or greater than 1. Okay. So while we'll check fast is not equals to null and fast dot next is not equals to null. In both cases, या तो फास्ट लास्ट नोड पे नहीं होना चाहिए या तो नल नहीं होना चाहिए. In both cases, we'll move slow is equals to slow dot next and fast equals to fast dot next. We are moving fast by 2 pointers and at the end we need to return slow. We'll run this. Submit. Done. Okay. Brute forces. Using brute force, we find the middle linear traversal, find the total number of nodes count, and then we reset the traversal point traverse count by 2 plus 1. And optimal solution is the previous method. What is optimal? Say initialize slow and fast. They are taking same variables also. Slow will advance one step and fast will advance same thing. Okay, I've done these questions before, like couple of years back. That's why I already had some idea on this. Next is reverse a linked list. We'll do one more question. This is the last question. Given the head of singly linked list, reverse the list and return the reverse list. 1 2 3 4 5. We need to make 5 4 3 2 1. In this case, one way, as I said initially, is that we take an array, we store all the values in that array, and then we traverse this linked list again and update these values. That is one way of doing this. Other way of doing this is that we keep track of the next pointer and update the next pointer of this. So what I'm saying is, we'll write a while loop. I'll check till when we need to do this. We'll take a current list node current equals to head. Now at each iteration we need a next node, so list node temp, let's say temp. Okay, now temp is the current dot next, so we are at temp is 2 and we also need a previous node. Dot, and let's take a previous as well, so list node previous as null, because we want to update the next of this also, right? So now we have current dot next, this is temp, so we have now we can update the next pointer of current because we have this saved in temp. So current dot next will become previous. Okay, and previous is current. Now previous is current, so previous will become this. That's how we can update the next node of this to this, and we'll do this till current dot next is not equals to null. Current dot next is not equals to null. What about current equals to previous also? Current equals to temp also, na? Current is now at this pointer. Wait, let me think again. What we are doing is, previous is current, previous is now at 2, current is now previous is 1, current is 2, current dot next is previous, current dot next is previous is null, 1 का previous 1 का next null हो गया, and previous is current, so previous is 1 now and current is temp. So in next iteration temp will become 3, current dot next is previous, so 2 का next 1 हो जाएगा, and now previous is 2 and current is temp is what? Temp is 3. At the last iteration current this is fine. So at the last iteration previous will become 5, so result is previous, will return previous. I think this should be fine. What happened? While current dot next is not equals to null. Okay, head can be null. Is it saying that head can be null? Okay, head can be null. So if head is null, then return. Or head dot next equals to null. In both cases, will return head. Okay, previous, what if I return current? Okay, current is not equals to null, previous return कर देंगे. Okay, fine. One more thing they are saying that a linked list can be reversed either iteratively or recursively. Can you implement both? So now we have done iteratively. Let's try the recursive approach. Okay, so I'll write one more method, which is public list node recursively list node head. Okay, and then So in this case we'll reverse the whole array and then make the next node of this to this, right? We'll make the current node as last node, and reverse this whole array, whole later part of the linked list. So what I'm saying is, we'll take the node temp as recursively reverse the rest of the linked list. So head dot next, and now we have temp as the as this one. Wait, where is the question? So we'll reverse this and then we'll make this as the last node. So for that we'll make so to make this as the last node, once this is reversed, we need to make this node attached to 2. So this will be head dot next as this. So basically we'll do head dot next as head, and then this is the last, so head dot next as null, and then this is the reversed array. So temp is basically the first element, right? For the reverse one, so we'll return temp, and the base case would be that if head is null, and this will fail if head dot next is also null. So head dot next is null. In both cases we can return head. I think this should work. We can keep this directly inside this method. Let me try to run. List node. Recursive. Okay, method name is reverse list. Submit. This is done. Next is reverse a linked list. Same question. I think first one is iterative, second is recursive. Detect a loop in linked list. Given head, the head of the linked list, determine if the linked list has a cycle in it. There is a cycle in linked list if there is some node in the list that can be reached again by continuously following next pointer. Initially, pos is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed in a parameter. Return true if there is a cycle in the linked list. So to find a cycle, one way of doing this is that we store each index, each node location. Once we traverse it, we keep track of them in a hash or something, a set, and then at each iteration we can check if that node is already visited or not. And at the end, if it is visited, then we'll return return true, otherwise we'll reach the end index, pointer, which will be pointing to null, and that denotes that there is no cycle in this. In this approach, time complexity is order of n, but space is order of n as well, because we are storing each of these indexes. Time complexity is not order of n, because we are searching also. For each node we are searching in the list or whatever we have, that if that element is present or not, that will also take time. This is not a good solution. What if we take the similar approach of having two pointers, a slow pointer and a fast pointer? Slow will move one step, fast will move two steps. Once we are at 3, slow will be at 2, fast will be at 0. Then slow it at 0, fast will be at 2. Then slow will be at 4, and fast will also reach 4. Once slow and fast are on the same position, then that means there is a cycle. Otherwise there is no cycle, right? And is it possible that even after doing this, slow and fast will never reach? I don't think that is possible. What I'm saying is, we'll take two pointers, list node slow equals to head, and list node fast equals to head, while fast is not equals to null and fast dot next is also not null, equals to null. We'll check if slow is equals to fast, then that means this contains a cycle, so return true. Otherwise we'll update slow. So slow is slow dot next and fast is fast dot next. And at the end, if we reach a null, that means there is no cycle, so return false. In this case, we are not taking any space, so time complexity is okay. In this case, this is the head node. Slow and fast both are here. So fast is not equals to null and fast dot next is not equals to null. In next iteration, we'll make slow equals to slow dot next. Slow will reach 2 and fast will reach null. China, all cases it is true. That is why I was getting correct result. Initially slow and fast तो equal है ही ना. Initially slow and fast are at the same index. That's why we are getting correct result. One thing we can do, instead of comparing, we can first move the pointers and then compare. Okay. That's all for today.